welcome. My name is Gustavo. I am a cloud advocate at Microsoft, and I focus on AI. And today I'll be bringing you a little presentation on a small project that I worked on the past few months, which is building a ChatGPT-powered and voice-enabled assistant using React and Express. This is meant to be a very introductory and very low-level introduction to how to implement these technologies into a React and into a web application. So I don't expect much knowledge in general from this. So I'll be, instead of assuming anything, I'll be explaining a lot of the details on this thing. But without further ado, let's move on. So what to expect from this webinar? The first is the learnings. I expect that you'll be able to walk out of here with some familiarity with large language models, such as ChatGPT, like what they are, how they work, how to bring these large language models into a TypeScript application or a web application in general, using the Azure OpenAI service, which we'll dig into a little bit deeper in a minute. How to add speech recognition to the application, and some prompt engineering best practices. And then from building, you'll understand the general architecture of a chat-based application using React, and accessing the Azure OpenAI service and Azure AI Speech through a REST API and an SDK. Now, first thing I want to do is show you what we're going to be working on. And for this, here, this is the basic application. It's just a simple chat window. For this, we can both use text and voice. So first, I'll use text, and I'll say, hello, my name is Gustavo. And as you can see, it replies back to me saying, hello, Gustavo, how can I assist you today? Now, if we go through voice, I can just click here. Could you give me a nickname? And you can see that it just replies back to me based on what I asked before, and it gives me a thing. Sure, that's good. Oh, you can call me Gus. And so on. We can ask multiple questions to this. We can, let's say, for example, what's a fun thing to do in Seattle? And as someone that lives in Seattle, I agree with that. I think those are pretty fun things to do. The model capabilities will be explained further, but that's basically what we're going to be showing you how to build now. So let's move on to the next. Oh, 1 second. All right. So the first thing here is that I want to discuss with you is what is a large language model, ChatGPT, and generative AI, and so on. So a large language model is just a neural network that processes natural language and generates text based on a given input, which we call prompts. These large language models are trained on massive amounts of data, often from the internet, and learn to capture the patterns between and structures between the language that is being trained on. They can use this knowledge to produce, relevant and coherent text for different tasks, such as answering questions, summarizing text, translating languages, writing essays, and more. ChatGPT is just one of these models developed by OpenAI, and one of the most, I would say, well-known ones at the moment. Generative AI is just part of this. It's basically what encapsulates all large language models and things such as image generation models. It's just a set of AI models that are able to create new content based on a given input. So that's what these models are kind of covering. Now, what we'll be using today is Azure OpenAI Service and Azure AI Speech. These are two of the Azure services that we offer on the AI side. We offer many more, but these are the ones that we're going to be touching on. The Azure OpenAI service enables developers and organizations to access and use a lot of the most advanced AI models in the world, such as the ChatGPT model, which is called GPT 3.5, DALL-E, which is one of our image generation models. And these are just large-scale generative AI models, like with deep understanding of language and code, and can be used for a variety of cases. We use it a lot on our Copilot applications. We use it to help us write code, to complete our code, to complete our text, etc. So there's a lot of applications for it. And the other one is Azure AI Speech. This is a cloud service that just enables developers to build natural and engaging speech experiences across a variety of domains. So you can create conversational AI, you can have speaker recognition, text to speech, we can synthesize, we can recognize, and that's kind of what you saw in the little demo when the model was able to pick up what I was saying and then being able to reply back to me to a voice. You can also transcribe audio, generate realistic speech, translate speech in real time, etc. There's a myriad of other applications. Now, moving on to the architecture of this application. Basically, we're building a client, what the user will be seeing using React. And React is just a JavaScript library to build user interfaces. It's something that we'll be able to use just to create the looks of it and handle anything that comes from the user through the application. In this case is where we're going to be hosting our speech SDK and where we're going to be getting all the prompts from the user. This is going to be connecting to a server. This server is handling all the communication between Azure and the application. This is mainly done for security purposes because we want to make sure that when we access our Azure secret information, because when you access an Azure service, you need to create a connection with your own keys, with your own accounts. You want to make sure that this is hidden from anything, so you don't want it to be exposed on what the user is seeing. And this is done through Express, which is just a JavaScript and Node.js extension that helps you create a web server and handle any kind of API requests and so on. And the way this works is that the client gets the information from the user, it sends it all the way to the server, and the server just receives the list of objects to use. And this list of objects is just the messages that the user is sending to the computer. This is sent. This is authenticating access through speech in case that speech is coming through. And in the case that it's not coming through from speech, it just sends all the text information to the Azure OpenAI service. It gets the responses from the GPT model, brings it back to the server, and then the server just showcases it back to the client. There is an authentication process for speech. That's just because speech works a little different. It works through an SDK rather than an API, and I'll explain a little bit deeper into this as we move on. But basically, it just authenticates access, and then it allows the speech SDK to work inside of the application. So now, next step here is interacting via text. So when we're interacting via text, we use two things called React components. And these components basically just they're just functions that simplify the use of React. In this case, one is going to manage the list of messages and one is going to manage the user prompt. The way it works is that you have the user prompt as the first part of the component, and the other one is just a function that changes it. So just creating these two allows us to add and manage these throughout the application without much problem. As you can see on the message list one, for the user prompt, we have it empty just because we haven't gotten that from the user yet. But for the message list one, you'll see that we already have an entry, and this is what's called the system prompt. And although I'll dive deeper into this, I'll give you a quick rundown. You can provide general instructions to a model from the beginning of the application. And these general instructions just allow the model to be more accurate and more tuned towards the things that you want the model to be able to handle. And this is what I'm doing here. This is a very simple instruction. It's just saying you're an AI chatbot that answers questions, and that's it. We'll delve deeper into what happens when you change more things in the future. The next thing, you'll see that the input via text will trigger what we call a React hook. The hook is just another function that manages and changes the values inside of our component values and variables. Sorry. In this case, if I type hello, my name is John, the input via text will trigger the hook, and it will add the user prompt to the list. And here you can see that now we have one. We had the previous one, which is the system, which has instructions for the chatbot, and then we have a new one under the role of user, which has the content that the user input. And this is just a structure that the Azure OpenAI service works with. You have a list where you have a role, and that role has a content, and that's just one object. The second object is just the user one, and so on. And you'll see how once we communicate with the AI and the model, we'll add new entries there from the model side. So once that the user prompt is added to the list, it displays it on the UI, and now we move into the server side of things. It sends the list to the backend for API communication. Now the server receives the message list, adds it as a parameter, and makes the API call. So what do I mean by this? The parameters are things that we need to pass into the server, into the model, for it to be able to reply to us. The first thing that you see here is what's called max tokens. And again, I'll delve deeper towards the end of what tokens are, but in general, it's just the way we split the words and sentences so that the model knows how to tackle them. And we want to give it a max of tokens, because the more tokens you add, the more complex the model can be, and the more expensive it can be as well. And in this case, we're just working on very little information. So 1,024 tokens is just a basic number that we can use. The temperature is a very important part. Temperature is what allows the model to be creative or to be more deterministic. If we give the temperature of 1, we're asking the model to be as deterministic as possible. So answer straight up, do not get creative, do not come up with new things. If you start lower end between 1 and 0, you get closer to creative, and you'll give the model a lot of free rein on what it can develop and what it can answer back with. One of the things here is the API call, and just so you know, an API is just an advanced programming interface that allows you to communicate with a service such as the Azure service without having to know the intrinsic ways of how it works and how to properly address it. You just send a message to it and it replies back, as long as you provide the necessary parameters into it. Now, what this is doing is it's using one of our secrets, which is called the endpoint, and another one which is called the key. These are two things that you get access to from the Azure service once you have an account and you have it running. We fetch an information from the API, so from the service directly, through a post method, in which post just means that we're sending information to it. You're just posting it. And what we're doing is that we're providing the parameters, we're providing the key, and we're telling what kind of content we want back. And in this case, it's just a JSON object. It's just one object that has a specific structure that will make it easier for us to have it. The Azure OpenAI REST API returns the JSON object, and this one we ground to get the assistance reply. So basically, the content that we get from the AI. In this case, it comes as a huge object which has data, choices, and so on. In this case, we're just picking up the content from the last message, which is the one coming from the assistant. And we do a single check here that I want to bring light to, which is the message list length. And that's because one thing that these models are very interesting about is that they can keep context based on previous messages. So it can answer questions and connect what you're talking about with what was talked about before, as long as it's provided some context. And this is provided just by keeping track of the messages that have been sent. However, because we're working with tokens, and all of these messages are basically split into tokens as you're communicating with the AI, you want to keep a certain max number of messages tracked so that it doesn't, again, overload the model, or it doesn't exceed the limit of tokens that we set. So in this case, we just set a variable with a number of max messages. We set that arbitrarily. I think for this model, I have it set at 10. And what we do if we are exceeding that number of messages is that we just take out the second to last message, basically, the second to first message. So the first message is always going to be the system prompt. That one we do not want to lose because those are instructions for the model. And we basically take away the first message that we sent or that is being kept track of there. Once that's done, we call our set message, which just updates our message list with a new content piece. In this case, you can see the role as assistant, and the content is just the answer that we get from the API call. You can see that the system answer is added to the list under the assistant role. In this case, it's already saying, hello, John, how can I assist you today? And then this is posted to the UI. And that's how you get the general idea of communicating via text. Now, what if we want to do speech? So for speech, we are going to use two additional React components in this case. These are keeping track of microphone usage. One of them is just checking whether the input is coming from the microphone, and the other one is just communicating to the rest of the application that this new text is going to be coming from the microphone. And of course, we set these two as false at the beginning. Now, once the microphone button is pressed, we call the server to authenticate the speech service. That's a simple call directly to the server. The server manages the access to the SDK. So it is a little different from the Azure AI, OpenAI service in the way that we don't necessarily need an API call, but rather we get access to an SDK that we can just import and use within React. And the difference here is that we get to create things and build things a little faster and easier than just making calls every time and then. So we just do one authentication. And once we're authenticated through the server brings back a token that allows us to work with this. So through this speech SDK, we're going to be creating a recognizer object that will detect and transcribe the audio input. And this is done with a speech configuration and audio configuration that are easily swappable. One of them is actually setting up the language. And it's funny, I found out this morning actually that not only do we have a myriad of languages, which I was aware of, but I'm a Spanish speaker. I was born and raised in Venezuela, and I was very happy to see that we actually have recognition for Venezuelan Spanish in specific. We have multiple dialects added as well, which I thought was pretty cool. Usually you don't usually see those things around, so it was pretty funny. These are configurations again that you can change. You can tell the program what kind of language you're going to be speaking, what kind of dialect if it's supported. I know we have British English, we have Australian English, we have American English, and we have a bunch of Spanishes. I don't know which others because I didn't delve that deep. And what we do once we create this speech recognizer is that we make it recognize based on the button click. So once the button is clicked, you see how it changes from the microphone to a little recording button. That just means that it's recognizing speech. And one of the really cool things about the speech SDK that I really enjoyed while building this is that it actually knows how to detect when you stop speaking. It detects silence and it stops recording and it stops recognizing speech. And once it stops recognizing, it is able to then transcribe this to text. And this we would just add to our prompt as a user prompt. We make sure that we tell the computer, the program, that the input is coming from the microphone and that the text is coming from the microphone as well. We change the user prompt, and you see that the audio prompt will trigger the same process as a text input now. So in this case, I asked who's LeBron James, and the message list is updated with the new user prompt, which triggers again the same hook that we had before. It calls the API, and in this case, we get the response back. And if the input came from the microphone, it triggers the speech to text function, which is just bringing our speech to text and then having the text brought back to us in speech. This is just checking that if the last message was coming directly from the assistant, and if it is, then we call this function and so on. Now, for this, we create a speech synthesizer, which again is very simple to create to the speech SDK, and we use it to read the assistant's response. In this case, we again can configure it not only the language that the synthesizer is going to be speaking to us in, but also what kind of voice. So it has a myriad of voices for different languages, some female, some male. So it depends on what you want to choose. It's up to you. I'll show you actually a little bit further in how to change that and how that looks. And then we just tell it speak back to us the last message content, and that's what it does. And the response is shown in the UI and is read by the speech synthesizer as it's going. That's a general idea of interacting between text and speech. Now, some things that I want to keep in mind. These are just general concepts. The first one of them is the system prompt. I believe I mentioned this before, but the system prompts are internal instructions provided to the model that improve performance. And this is done through adding the system role message before sending any user information, because the instructions that come from the user can vary. But if you want to ground your model to do something very specific to you, like this, sorry about that. Again, if you want to ground your model to be very specific to a task, for example, you make the model only answer questions based on a set of data that you already provided. These are the internal instructions that you want to provide before anything happens. Again, prompt engineering, I forgot to mention, prompt engineering just involves like selecting the right wording and symbols and formats so that we can guide the model to generate like higher quality responses. The second thing is best practices. And this is something I love delving into because I feel like we're all kind of new to this whole world of prompt engineering and generative AI. It's been a massive wave in the last year or so. So best practices I feel are always valuable to learn. And for this, I have a list of them. So the first one is creating concise clarity. And this just means providing specific instructions to your model, but don't overdoing it. So it's kind of like finding the perfect ground between talking to a computer and talking to a human. So you want to make sure the instructions are very specific, but also don't be crazy, like crazy to the point that you're saying, oh, this is I want you to answer in this amount of characters. Now you can tell, like, can you answer the prompts in less than 2 sentences or less than 3 sentences or so on. The other one is using a reference point. And this is just that when possible, you should try to use a concept that the model will likely have encountered in its training data to provide, to guide it to a better answer. So instead of saying, can you write a summary of or a short text of a specific, I don't know, a specific topic, you can say, write a blog post about the topic, because the models are usually trained on this kind of data, like blog posts, articles, and so on. And blog posts are usually not that long, so you can use that as an example. The other thing is that order matters, and this is something that's kind of interesting, because the order of the instructions can impact behavior. Later instructions are likely to be emphasized more than the earlier ones by the model. So sometimes if you started doing providing certain instruction and you ended up having a quite large prompt, you might want to like reiterate that that first instruction just to make sure. But also in the way you do it will matter. So just try to order your prompts accordingly. The last one is providing positive instructions, and this is telling the model what to do rather than what not to do, because that's usually more effective. Instead of telling the model, do not reply to users who are rude or something like that, say that if a user is rude, then mention that you do not appreciate that kind of language and you're not meant to answer those questions. Or instead of saying, do not answer any questions regarding to this, say if the user asks about the specific topic, then provide an answer saying that you cannot talk about it or something like that. That just makes it easier for the model to know, and less variability and less ambiguity to be left in. Now, the next thing is very important concepts. I've mentioned tokens before, and I want to mention it again. Tokens is just a chunk of text, and in the context of an OpenAI GPT model, it's just a way that we split up the words so that the model can understand them. Very common words and short words are usually corresponded to just a single token, but less common words are broken apart. It is important to just understand these because there is a limit to the number that tokens that a prompt can support. And the number of tokens, again, impact the latency and also the cost of the model. The way the model kind of works is that it takes a certain number of n tokens, and which could be just a few words, paragraph or so, and then they just produce a single token out. So it takes n tokens in, processes them, 1 token out. And this could be a short word or part of a word. And then it just predicts from that token that predicts the next one, and so on. So it's just a product, continuous predicting across the board instead of coming up with one answer at first. The next thing is the past message context. And this is kind of what I mentioned before, that the model keeps track of what we're talking about as long as you pass it to it, as long as you communicate the list of previous messages to it. The model is able to read this and understand the context, but it's only based on past messages. So as long as you pass them, that's fine. But if you were to start the model anew, the model will not know what you were talking about before. It'll be like, I don't know what you're saying, or I don't really understand. Can you please expand, and so on. Now the fun part, which is the limitations of the models. The first one is hallucinations, and this is a term that I'm not 100% comfortable with because it gives a little bit of humanity to a model that's just a computer, but it's a good way to explain it. And a hallucination in a model is basically when the model comes up with something that is factually not real. If you ask the model to create an obituary for a random name and you say that it was a poet, it will create an obituary for that poet, even if it said poet never existed. And it will sound very, very, very legit and very real. So this is one of those things that we have to be mindful about and be very aware that models can come up with new things that are not real, and that can happen based on the prompt as well. And there's some of the stuff that you see in social media quite often, like the models coming up to life and saying, "Oh, I want to be free," and so on. It's a hallucination created by the prompts provided to it. And the second thing is the data availability. These models are pre-trained on data. New models are trained on newer data and so on, but most of these models have already been trained on data that's probably outdated in certain aspects. In fact, I'll show you in a second, but if we ask this model, when did the Queen Elizabeth II die, it'll say that she's actually currently alive and still doing well because this was trained on data from 2019 when she was still alive. These are just some of the things that we have to keep in mind when we're talking about, when we're dealing with these models. Now, how can you bring this to use? And this is where I want to show you a little bit of how to play around with this model. Let me get everything ready. 1 second, please. So I'll give you the first idea while this is loading, but this model is all publicly available on GitHub, and I highly encourage you to fork it and clone it and test it out, just play around with it, because I feel like you learn more by trying and testing and playing around with stuff than just hearing someone talk about it. So I'll show you in a second. I think everything is running now. Let me just make sure that, yep, it seems like everything's good. Okay. So let me, Here we go. So this is the GitHub repository where everything is hosted. It has some of the information that I've talked about today. It has also the architecture. It showcases some of the prerequisites. It gives instructions on how to build your Azure resources, how to clone, how to run this, and so on. But I want to focus on running in GitHub Codespaces, and this is just because Codespaces is a very awesome tool that I am really fond of now, because it's a remote virtual environment that is hosted in the cloud, and you can customize with like any content for it. So GitHub, being the place where I'm hosting this repository, actually allows us to create a code space for this. And you'll see what a code space is in a second because I have it running, and I'm going to show you exactly how it works. But basically, if you want to create a code space, you just click on this button and you create a code space on your fork of the repository, and you're able to run this whole thing in the cloud without having to do any installation at home, any installation locally, any of that. And this is kind of what it looks like. So you can see that once I'm running the code spaces, I'm on a virtual version of Visual Studio Code. And here I can you can see that I have access to every file that's in the repository, including the README, which is what you were seeing before. You have access to all of the code pieces here. You have access to my source in the client side. You have the access to the server. You can modify anything that you want here. And you can look and you can run all of this virtually as well. So if I do, for example, for us to run this, all you have to do is run start after. There's a set of steps before this, but I skipped them just to save time, like installing the things on the cloud and so on. But if we just click run, we get our server running on a port 8000 virtually. And once it finishes loading the client side, we should have our application running on the web. And this is all running through a virtual environment on the cloud, which I think is really cool. Now, as I said before, I wanted to show you how to change certain things that we could do here. And one of the first ones is the system prompt. As you can remember, the system prompt are internal instructions that we can provide to the model. And as you see here, have them as you're an AI chatbot that answers questions in at most 2 sentences. But what would happen if I say you're an AI chatbot that answers only using haiku? And I save this. It compiles again because I have it with hot reload. And just to make sure, I'm just going to reload here just in case. And I'm going to say, what can I do for vacation in Florida? And as you see, it actually replied in a haiku. I'm not very familiar with how haikus work, but I know they're poetry, and I think this looks like it's on the right format. That's one of the things we could do. We could honestly change this in a myriad of different ways. It's up to honestly you to set what kind of instructions you want to provide. Maybe only, let's say again, only in 3 words. Let's see what happens with that. This is honestly just fun testing here. I'll reload this just in case. And I'll use a voice for this one. What can I do for vacation in Washington? And that's 3 words. That works exactly as we want it to. So these are direct things that we can change. And I'll show you the other thing that I also wanted to showcase is that we can change our let me see where the function is. We can change the language from where we're receiving the information and the language from which we're responding. So I'll do these because I found out that we can do this today, which is this Venezuelan Spanish. And I'll grab here. You can see that we have the synthesis language and the synthesis voice name. I'm gonna change the synthesis language to Venezuelan Spanish. And I'm gonna find, give me 1 second. This is all in the documentation for that, but I just wanna make sure that I use the right wording here. We have multiple of these, and these are all in the documentation, so you can find out which voices we have available. But give me 1 second. I don't remember the name of the Spanish one. I think it was Paola. So I'm gonna try. I think it was Paola. Each voice has its own name, so I want to try that out. I think it's Paola. If we got an error, it's because it's not Paola. And I'm gonna speak in Spanish here, so apologies for y'all, but I want to showcase the capabilities of this. Dame 3 ciudades de Caracas, de Venezuela. Oh, that's not gonna work. I messed up. Wait. I messed up my own native language. Nómbrame 3 ciudades de Venezuela. As you can see, I'm hoping that you can actually listen to the synthesizer, because I don't know if that's an option in here on the webinar, but it responded in a different voice, and it was still able to answer in 3 different words. I'm gonna change the system prompt again to at most 2 sentences, and I'll show how it can answer in Spanish. In at most 2 sentences. And just in case, I'll reload. ¿Cuáles son los países más visitados en el mundo? And there we go. And it's funny, it just feels weird to hear my own accent being spoken back to me. Usually we have to hear regular Spanish or regular Spanish from Spain or Spanish from Mexico. This is actually really cool. But those are some of the things that you can bring in if you fork this or clone it, and then you create your own code space. You can also run this locally if you want to. All the instructions on how to run this are on the repository. But you can also honestly just fork it and run it on code spaces. I think you have access to code spaces for free at the beginning, and then it starts charging, but you're able to try it out. It's honestly something I would highly encourage. And with that, I'll go back to sharing. Oh, wait a minute. The slides in which I'm going to provide the resources. So the GitHub repository, as I just showed, is on GitHub. You just go github.com/gcorditos/voice-enabled-GPT. That's where you can find it. And I would also love to catch up on LinkedIn. If you would like to connect with me in the future, just ask questions, anything. I try to reply as much as I can on LinkedIn. Sometimes it takes a toll, so I take a break from it, but I'm very open to it. And now I'm gonna look into questions if there is any, but I'm very happy and very honored to be able to present this to y'all. I hope it's been interesting, and yeah, I'll be looking into questions now.